Hi guys, this is Akshay, and today we will be discussing an algorithm problem that was asked to me in one of the rounds at Google. So, here is the problem. Given a list of 24-hour clock time points in HHMM format, return the minimum minutes difference between any two time points in the list. The examples are 2359 and 00. So you are given strings of time points and you need to find the minimum difference between any two of those strings. So uh, as you can imagine that we cannot simply find the difference between two strings, we have to convert them into integers. So that is first sub part of the problem, that to read the string and parse an integer value out of it and convert all of those values into minutes, because you need to return the minimum minutes difference. Here minutes is mentioned in bold, so that's an important piece of information. So these two values here, 2359 and 200, the difference is 1, because just before this one is 12 a.m. and this one is just 1 minute before 12 a.m. Yeah. And here in this case you have two timestamps, two same timestamps, so the minimum difference between those two is 0. So what's the first idea that comes to your mind when you see this question? Let's forget for a second that you are given these values in strings, rather you are given these values in minutes form only. So the first value is 23 into 60 plus 59, yeah? And the second value is 0. And let's take this example because this one is bigger, and the third value is also yeah, 0. So this can be translated to this. So what's the first thing that comes to your mind when you see this sort of problem? So how are you going to approach it in an efficient manner? We can say that if a particular if a particular value has occurred two times, we can find the minimum difference between those two, and the answer in this case turns out to be 0. But what if you had something like, let's say, 0 0 0 into 24 plus 5 instead of this 0? Yeah. So here in this case, again, the answer would have been this value, that is 5 minutes minus 0. So answer would have been 5 minutes. So don't you think our job would have been that much easier had we ensured that our input is in fact sorted? So that brings us to the second intuition in this problem. The first being, let's just write the subparts of this problem as to dos. So always try to think of a problem at high levels first rather than going into implementational details, that how am I going to implement. Let's just say you have some genie beside you who helps you to implement those functions. Your job is to think about the algorithmic structure, how the code's flow is going to go. So the first to do would be to parse the string, parse the integer minutes from given strings. This is going to take entire order of n items, order of n time. The time complexity would be order of n, where n is the number of entries in your time points list. Okay. The second part is to ensure that your time points that you are storing is sorted. So to do, again, sort the time points and time points minutes. Now sorting the time points is going to take you n log n time, right? And this is the idea that you should come up with as fast as possible in an interview, because this is a brute force idea. Okay, the sooner you express your brute force ideas in the interview, the sooner your interview moves on, and you might be able to get some hints from the interviewer. If there is any particular intuition required in this problem, in any problem, the interviewer will guide you towards that intuition. So yeah. And finally, once you have like the sorted input, let's say this input was a bit more large. It was 3 minutes, then 10 minutes, then 50 minutes, then 1 hour 50 minutes. That is 110 minutes, and so on and so forth. So if had you been able to sort this thing, so your array would have become 0, 3, 5, 10, 15, 110, and finally this whatever value, this whatever large value this is, that, so this thing, let's call it x, so x, yeah. So then you could have simply traversed your array, find out the difference between two consecutive elements, and whichever the difference is minimum, you are able to return that. So just traversing the entire array would take you order of n time. Okay, so order of n time, yes. But in the entire code, your n log n is the being the dominant factor will dictate your time complexity of the code. So now the interviewer might ask you that n log n we can do actually better than that. So how do we do better than that? There's a key observation here to be made, which is that your input time points, will vary between 0, 0 to 2359. You cannot express any time in HHMM format outside of this range. So you have a defined input space. Now, which is the sorting function? Because you have to sort this. So, which is the sorting function that works very well when your input size is fixed? The answer is none other than bucket sort. Yeah, and that is the crux of the problem. This is a bucket sort problem, a not commonly used algorithm, sorting algorithm, but you can sometimes get stumped by this in the interview. So if you are able to store the information whether any time point between this range has occurred in your input or not, if you're able to store that, then the job becomes all that bit easier. For example, in this particular case, the time point 0 has occurred once. So you, let's say, create an array of yeah, let's say create an array I of I indexes ranging from 0, 1, 2, 3, 4, 5, 6, and so on and so forth till 23 into 59. And you just mark in this array whether this particular value has occurred in time points or not, or in our case, this particular input or not. So 0 has occurred, that is true. 1 has occurred, no, that is not true. 2 has occurred, no, that is not true. 3 has occurred, yes, that has occurred. And if it has occurred, if 3 is not the first element, then that means some element has occurred before 3, and you find the difference between these two. So okay, the difference between 3 and 0 is 3. So right now your minimum difference is 3 in this case. 4 has not occurred, no. 4 has not occurred, yeah. So 0, and 5 has occurred. So now the last item before 5 that had occurred is 3, and the difference between these two is 2, which is smaller than your minimum difference. So yeah, in this case the answer would be 2. Let's proceed ahead. 6 has not occurred, 0, and so on and so forth till you reach 10, which has occurred. Then again you reach 15, which has again occurred, and finally the largest time stamp that has occurred again. So this way, once you traverse this array, you will find you will find your minimum difference. But yeah, this sounds all fine and dandy, but there's an edge case to be taken care of here. As is always the case with Google interviews. In Google interviews in particular, you have to be very cautious about edge cases. Writing a code is not the most difficult part, but coming up with all the edge cases yourself is the tricky part. So you have to be very vigilant. So what if, let's say in this case, none of these values had occurred? You only had 2359. Yeah, 2359. Yeah, and all of these values would have been 0. 0, 0, 0, and 0. So in your case, the first value that would have occurred is 0, and the final value, the only other value, is 2359, in which case you try to find the difference, and the difference turns out to be a huge number. Right, and that is 2359 minus 0. So but the minimum time difference actually, as you know, is 1. So what we need to do here is we need to think of this particular 0 as the next day. So the minimum difference is nothing but the difference between these two numbers, and min is equal to minimum difference, min of min diff so far, and the other day, that is, you just add 24 hours into it and find the difference. Then if this is the latest element that has occurred, so let it be called latest, and this is the earliest element, so let it be called earliest. So the difference between these two things will give you and the other time difference, and you find the minimum between these two. Then your answer is like correct, absolutely correct. So let's just code this down. So first part is I will be coding in Java. You can choose the language of your comfort. So here first we have to prepare an array. Now, what would be the size of that array that would hold this information, whether a time period has occurred or not? In our case, it would be nothing but the size of the total time window. Let's call it that, is equal to 24 hours into 60 minutes. Any time that we will get in this time points string will be within this total time window, and we call it occurrence is equal to new int total time window. Yeah, and initially we initialize it with -1. So till now nothing, no time has shown an occurrence in this array. Now we try to populate this array. So this would be a string time points, time point in time points. Yeah. In Java we have a nifty little function to split the string, and we are going to use that. So let me call it input is equal to time point dot split. Yeah, basically this will split the string into two halves, the first half being this and the second half being this. And how do we determine time from that? So time is equal to the first value, integer dot parseInt input 0. The first index number, it can be 0 or anything, multiplied by 60, because 1 hour contains 60 minutes. Yeah, and integer dot parseInt, so input 1. Yeah. So now you have your time in minutes, and you check if occurrence of time is already 1. So like in this case, there are two elements of with same time value. And first you go there, you mark it 1. Now when you again come here, you see that, okay, oh, this is already marked 1. You can simply return 0 from here, because that is the minimum difference. Your difference cannot be lower than 0. Otherwise, you can mark it 1. Yeah. So the first part is done thanks to our Genie. Yeah. Now we have in fact improved upon this thing, because our occurrence time is already sorted, right? Because we have just constructed it that way. We've intelligently constructed it that way. So we do not have to sort this thing. And this is how we save our time. This is how we better the time complexity of our uh, program. Now this is the order of n-thing, in which we will parse the occurrence to find the minimum difference. Yeah. So let's just implement that quickly. For int I is equal to 0, I less than total time window I plus plus. So if occurrence of I is not equal to 1, and for example these numbers, so we don't bother about them. There's nothing to be done here. We just move on to the next one. Okay. Yeah, before that we need to initialize some variables. Yep, very important. Int mindiff, which will be our result, which will return. This is nothing but the maximum value we can think of. Any number will be smaller than that. Now yeah, the other thing is to know that which is the last index that we have visited, which is the last time that we have seen. So last time we can initialize it to be -1, because so far we have not seen any time whatsoever. Then we need to also store the information about latest and earliest, which we'll use later. So latest is equal to integer dot min value. Yeah. And the earliest is going to be integer dot max value, because we want the earliest to be the smallest possible value, so we take it from one extreme and keep reducing, like as we see more and more entries. So yeah, all the initializations are done. We check if the last time is equal to -1. That means we have not yet seen any, we have not even encountered our first time occurrence, so in which case we will just initialize this with I. So this is the time, because if it is not 1, then we would have continued to the next I, but because this statement has not triggered, that means we have encountered an occurrence, so we just initialize it with that. Else what we do is basically your min-diff. So basically, if our last time is not -1, that means we have already seen an occurrence and we want to find the difference between the current occurrence and the last encountered one. So mat.min, min-diff, and I minus. So I is on the latest one and last time. Yeah. And we also need to initialize last time with I. And we finally need to update our latest and the earliest. So latest is mat.max, latest in I, and earliest is equal to mat.min, earliest of I. Yeah, because we are limiting, we are making earliest smaller and latest larger and larger from min value, earliest smaller and smaller from max value. Yeah. Now finally we return our answer. If min difference is the lowest, that is great. Otherwise, what we check is what is the difference between your latest and earliest time periods. You do not want to earliest, yeah. You do not want to be dealing with that edge case. Yeah. You do not want to be missing dealing with that edge case, to be precise. Yeah. And let's give it a run. Yeah, some array.fill compile errors have occurred. We will just fix those. Arrays.fill and cannot find symbol input 1. So input of I, yeah, not I, but rather 1. And yeah, our cases have passed. Let's just submit and check. Voila. Yeah. So this was the minimum time difference question. I would suggest you go and practice yourself to internalize the concepts better. And see you in the next class. Bye bye.